Hello everybody, welcome to the session. This session is about a search tool, a search bar essentially that we built with myself, Ilgun, and also my colleague Cedric. But today, unfortunately, he couldn't make it to here, so it's going to be only me presenting the topic to you. Let's start directly since it's a quickie. First thing we want to mention is that we are not researchers, which means that we are developers like yourself, well, given that you are developers, of course. So the main thing here is that if there would be a takeaway from this session, it would be that the entry barrier to machine learning nowadays is quite easy, so that everyone actually could do it, well, given the interest, of course. And, well, so it's a search tool. It's called Periscope. It's just a coincidence. It has nothing to do with the streaming tool that you might know, but, yeah, we didn't know it either. Anyhow, so this is how it looks like. It's basically open source. It's based on Vadin, which is a web framework. On the right, you can see the image. Basically, in this example, user typed car, and then we provide them a bunch of results. And also, as you see, there is website, which is actually the name of the result provider that we will speak about later. And also note that there is a microphone icon in the right, which actually gives the idea that we do speech recognition, which we will talk about also. And also there are links to the main project, and I work for Magnolia CMS, so there is a Magnolia integration also, but it's completely free and open source. So this is how it looks like. It does live result listing. So in this example, user will type car, and then we will show them a bunch of results from websites, and the other one is from Wikipedia. So keep it in mind. And user can also freely traverse or move down or move up in the results, and with the enter key, they can delegate to certain action, which we will see later. So this is how it looks like. This is the main Periscope. As I mentioned before, there are result suppliers, which actually supply those results that we actually happen to show to the user in the end. So these result suppliers are quite easy to write. They are completely pluggable to the tool. And this is how it looks like. I already mentioned Wikipedia and the websites, which is actually, if you implement the title, that's where the title comes from. It's just a plain string. The interesting thing happens in the search function, actually. Given the search query that user types in or speaks to or whatnot, you receive a bunch of results, which happen to be a list of results in this case. And if something goes wrong, which we hope not, but then you can throw search failed exception. So our goals, we had actually 3 goals that actually we use machine learning to. First one is searchable images. So in this example, as you see, we like cats. Well, I guess everyone does. Anyhow, so when the user types cat, it will go and fetch the cats in the particular database or data source. And, well, this is solved by deep learning. We happen to use ResNet 50, which is a residual network, which happen to have 50 layers. And why we use it is that because it's offered by many frameworks, many tools already, the pre-trained ResNet 50, so that you can just use the model like we do. So we didn't reinvent the wheel there. And also 152-layer variant happened to be in the first place in some competition. Also, there's a link in below, which actually points to the paper, and it's actually really interesting read. Have a look at it if you are interested with the topic. And, well, so how those networks are trained? Well, it's actually straightforward. You can do it yourself too. For us, we use ImageNet database, which has millions of labeled images. It is based on WordNet nouns. WordNet itself is a database. So there are more than 500 images per class. Let's say you have cat and you have 500 cat images. And these are pre-labeled so that you can train your network. And as I mentioned before, pre-trained networks are available already. And, well, there is a Magnolia implementation for it, which the link is the following. It's free, it's open source. In this case, if you are familiar with JCR, we store the properties, but you can store it anywhere you want. And this is just happened to be Magnolia implementation, but the main algorithm and the main network is already there, so you can just adjust it to your needs. And the second one was speech recognition. So think about a case if you are lazy or if you have some disabilities, you might really need to speak to the machine, right? Well, I am lazy in this case, so I like speaking to it when it understands me, of course, but it's pretty accurate, we will see. So this is what we used. There is a web speech API, which is actually embedded in the browser so that you can use it. Currently, it's only available in Chrome and also Firefox, but it's in the spec, so it's going to be available eventually for all browsers. And it's pretty accurate. So this is just JavaScript, and basically you just create a new instance of the speech recognition, you get your recognition, and then you have a lambda which gets the result events, and then this event, well, for instance, for English, it's 0. And the second one, 0. 0 is the variant of it. So it gives you a bunch of results, and with the confidency, so you can just check and which is better, and then return to the backend. So in this example in particular, we return the transcript, which is the text, to the backend to do the search, but you can do whatever. And you have to start the recognition, of course. And the most interesting thing, according to me at least, is the adaptive result order that we do. It's actually ranking. So imagine a search tool. Google already does it, right? Well, others too. When you type car let's say you selected the fourth one. Next time when you go and type car, you want to rank it higher. So the user will be directly seeing it at the first rank, right? So we did this with sort of deep neural network. It was easily achievable. So when user types car in the second round, we directly show the user as the first rank. And for this, well, the main challenge was actually the following. We have two-dimensional array, which happen to have 128 code points in ASCII. And also we have max character, which is 15. So this is our input. And then we do an initial convolution, because imagine a case, if you're searching for Facebook, you don't really write Facebook there. You write face, you write face B, maybe you write FB. But this is the main challenge, because all these actually initial characters or the small characters go to a same page. So we have to associate them somehow. And therefore, we did the following. We associate the three adjacent characters and then train our network linked. And this is how our output layer looks like. We have n units, which is the size of the result set. And the neural network gives us the results as the following, from somewhere between 0 and 1. The higher, the better. And it also gives the estimation of the relevance according to. And this is semi-supervised learning, because some results are coming from the network, some of them are directly coming from the result providers, but they're not ranked. So this is our setup. It is not a very deep network. As I said, we have the input layer, we have the initial convolution, and we have just a bunch of fully connected layers. And in the end, we get an output. So it's actually demo time. Enough talking. First thing I want to show is speech recognition. This is Magnolia, by the way. This is how it looks like. Let's try what? Alp. Okay, that's demo effect. Okay. Of course, it will not work when I want it to work. Alp. Okay, well, great. Well, anyhow, if you were to write Alp, which I will try later, maybe I really can't pronounce it. I'm not a native speaker, as you might guess. And then we already have the pre-tagged images, which actually point to directly from our database. So we can see actually if they're accurate or not. Let's take, for instance, the fourth one. We go, we check, there's a small preview. Well, it really looks like ARPs, so I take it as correct one. And the next time when I go and actually type ALP, as you see, it's ranked higher. So this is what I was talking about, ranking. But I want to try one more time the speech recognition. I don't know what to say, though. Well, yeah, let's stick with the cats. cat. Hold on a minute. It really doesn't work. Okay. It thought it's text. Okay. If I really speak to it, if I really speak to you, well, then what's wrong? Anyhow, demo effect. It works, I promise, try it. Well, accent is the problem. Let's try. Java? Yeah, it does. So as you see, actually, it directly tries to, we have the concept of voice comments. So if there is just one result, we directly try and execute whatever the comment if you predefine it. So that's why it actually says the comment fails. So you can also use it as such. For really tricky cases where the user really goes and have to do many clicks, you can just do it by the vocal comments. And well, more interesting case would be for the ranking especially is that imagine a case where you search for a car. Well, I get a bunch of results, and let's say I'm interested with 1 car games. Okay, that's interesting website. And then next time when I go, it's the first ranked one, right? So far so good. But what happens if I put car G? Well, I'm not really interested with the cars, right? So, but I want to actually, let's say, go to SPB cargo. So what I expect is that the car should go to the SPB cargo, but the car should go to the car games. And since the training is happening now, as you see, now the first item is the car. And with the G, well, it is not really the cargo. Okay. It has to learn. Now it's okay. So, as you might guess, our learning rate is quite high because we have limited users, and this is on the fly directly. We don't have a pre-trained model for that. And frankly, that would be it from me. And the takeaways would be from this session is UX can really benefit from machine learning, and deep learning has matured. It was fairly straightforward for us to go and build something. Of course, we had to read some books. I'm not going to claim it's super easy, but I can easily tell you don't need a PhD for that. I don't have one. And the entry barriers are quite low nowadays. So yeah, that's it from me. Any questions?